Hey, good day, grade 8 students. We are now in quarter 4, week 7 of our regular session. Our session is all about count the number of occurrences of outcome in an experiment. The methods are by table, tree diagram, systematic listing, and fundamental counting principles. So we have four methods that we're going to use in order for us to determine the number of counts of occurrences of a certain experiment. Okay. So let's have our first example. You have a coin and a six-sided die, or six-faced die rather. You want to get a combination of head and two. Is it possible to get the combination in 5 trials? Then try it. So first, let us determine what are the possible outcome of a coin and a six-sided die. So let's say a fair coin. Let's draw a coin. And let's say you have a coin, yeah, a 1 peso coin, and you have a six-sided die. So let's say this die has six faces, six-face die. And okay, so for head, we know that the sample space is head and tail. For coin, for die, you have one, two, three, 4, 5, and 6. So if these two things will throw together simultaneously, we have we need to list down the possible combinations. So in systematic listing, a head can be paired by one. So head one, head two, head three, head four, head five, and head six. For the tail, you have tail one, tail two, tail three, tail four, tail five, and tail six. So if we count the total, we have 12. We have the cardinality of 12 sample space with these two things, with this coin and uh, die. Now, if we're going to put it in the table, what I have here in the left part, in the row part, you have head and tail. That is for the coin. For die, you have 1, 2, 3, 4, 5, 6 in each column. So getting the combination, you have head 1, tail 1, head 2, tail 2, head 3, tail 3, head 4, tail 4, head 5, tail 5, and head 6, tail 6. So if we're going to count, we have 12. We have the cardinality of 12 as well. So as you can see, we use different methods, but we are consistent with the cardinality of the sample space. Now let's have the tree diagram. So in the left part, you have here head and tail, which is the outcome for coin. And the right part, you have 1, 2, 3, 4, 5, 6, which is the outcome for die. So if head is paired with each possible outcomes of die, you have 6 pairs. The same goes with tail. If it is paired with the 6 numbers, you have 6 pairs as well. So the total of 12. So that is by tree diagram. You're going to draw an arrow, which is like a branch like arrow for uh, the sample space. That's why it's called tree diagram because it has tree like branches of arrow. Now, let's have the fundamental counting principles. So in fundamental counting of principles, it states that if there is m ways of occurrences and n ways to do another, then there is m times n ways of doing both. So coins has an m ways, meaning to say two cardinality or two ways in getting this two ways in presenting the outcome, which is head and tail. In die, we have n ways, which is a number of ways in presenting uh, the outcomes. So you have here 6 ways. So multiplying, you have 2 times 6 will give you 12 ways. So there are cardinality of 12 possible outcomes for the two things when we're going to throw them simultaneously. So uh, we want a combination of head and tail. So that is possible because if we're going to check on the systematic listing, you have here head and two. In table head two, this one. In tree diagram, you have that one. In fundamental counting principles, the key is to determine how many possible outcomes are there. So head two is already included in 12 ways. So there are 12 possible outcomes. Now, when it comes to getting the combination in 5 trials, we're going to discuss that on the later part of the lesson. So let us have our first example. There are 5 shirts, blue, red, white, black, and floral, and 3 pants, maong, brown, black, in Maki's closet. How many possible outfits can Maki, I think it's Maki, Miss Maki have? So, let's have first what are the things that inside the closet of Maki. He has shirts and pants. So Maki has 5 shirts, which are blue, red, white, black, and floral. So by table, we list down the shirts of Maki, which is placed in column. In pants, we have maong, brown, and black, which is placed in row part of our table. So getting the combination of this, so maong paired with blue, that's one outfit. Red with maong, white maong, black maong, floral maong. So those are 5 outfits with 5 shirts and 1 pants. So 5 outfits. What if we have brown? So you have here blue brown, red brown, white brown, brown maong. No, it's not brown maong, black brown. I think it's black brown or brown black. Floral brown. Okay. So a total of 10 outfits if we have the 2 pants and 5 shirts. Then the last one, blue black. Okay, blue black, red black, white black, both black, black black, floral black. So a total of 15 outfits. There will be 15 outfits that Maki can have, given that he has a 5 shirts and 3 pants. Okay. Now, if we want to try the systematic listing, of course, you have to list down all the possible combinations of outfit by Maki. So you have here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So there is a 13. There is a 15 possible outfits for that. Now, by tree diagram, we have at the left part, we have the shirts. The right part, we have the pants. So we're going to pair them. So as you can see, blue shirts can be paired with the 3 pants. So that's 3. Same with red, white, black, and floral. So a total of 15 with a cardinality of 15 outfits. So as you can see, from table to systematic listing to tree diagram, the number of possible outfits are consistent. So meaning to say, your answer is correct if they have a consistent number of possible outcomes. So if we're going to confirm it in fundamental counting principles, shirts has M, so we have M times N. pulses M. So 5 times 3, you got 15 ways. Okay. So what I have here is remaining tasks for us to do the practice or solve later. So you have here two pieces of six-sided dice. So how many possible outcomes are there if we have two pieces of six-sided die? So the first die has 6, and the second die has also 6. So that would be 6 times 6 will give you 36. So if you're using table, tree diagram, and systematic listing, see to it that there are cardinality of 36 possible outcomes for them. Okay? For the second one, 3 pants, blue, red, white, 3 pairs of shoes, rubber, leather, and synthetic. So how many outfits are there? So if there are 3 pants times 3 pairs of shoes, so you have here 9. There are 9 possible outcomes. For number 3, you have 5 noodles, beef, chicken, pork, seafoods, veggie, and 2 buns. Okay. So you have here 5 times 2. You have here 10. So the cardinality is 10. For hair clips, white and black, ribbons, 3 ribbons, you have 2 times 3. That would be 6. So the cardinality for this is 6. You have here 3 cakes and 3 drinks. So you have 3 times 3 equals 9. So there are 9 combinations for your snack. So what you can do is to confirm the number of possible outcomes through table, tree diagram, or systematic listing. Okay, so what are the ways in getting the number of possible outcomes? The ways are by experiment, by table, tree diagram, systematic listing, and fundamental counting principles. So if you still have question, you can put your questions on comment section, or you can uh, you can drop by any questions uh, that you think related. Okay. So that would be the end. Let's have our next session. So see you when I see you.